Everything has its limits, except for mathematics, because as soon as we discover something unsolvable, we can define something to be a solution, and it becomes solvable. That's why I was surprised to hear that you can't divide by 0, which just seemed to be an incredibly lazy excuse for something more complicated. Okay, you just have to live with some facts, but there was something that upset me even more. We worked around with negative exponents, and my teacher explained how when the exponent gets smaller, the solution also shrinks. I couldn't help but wonder what were to happen if the exponent got infinitely small. Is the solution just a 1 with infinitely many zeros in front of it? Can you construct other cool numbers? To answer this question, I will tell you something about Greece. I mean, ancient Greece. Who cares about the present Greece? In those days, infinite sums and infinity in general was trending. Hasn't really changed since then very much, right? Although the limit was only introduced in the 19th century, the idea existed for much longer. Archimedes, for example, used infinite sums to approximate pi. But what exactly is a limit then? And what does it have to do with infinity? In essence, a limit describes something that is being approached. I'll just show it using an example. Instead of saying 0 divides something, let's say something that approaches 0 divides the number. Notice that as the number gets smaller, the solution grows. In fact, we can make the solution as big as we want, and that's why we say that it approaches infinity. You probably also noticed that I wrote positive 0. That's because we can also approach 0 from the negative side, which would give negative infinity as a solution. So we can get two different solutions depending on what direction we come from, which is why division by 0 is such a problem. But in one specific case, we can get a different solution. When we divide 0 by 0, we can say that it is always, with no exception, 1. Which is actually not that hard to see, because whatever number we plug into the x, it will always equal 1, so we can say that it approaches 1. Now that we got the boring loser problems out of the way, let's focus on the problem I proposed before. So you might have already expected that what we see is that as the exponent approaches 0, the solution also does. But you might also say that the solution approaches this infinitely small thing. So which one is it now? Sadly, it's 0, and all of my exciting childhood dreams are ruined. Why is it 0? Because infinitely small things just don't exist in the real numbers. Although these cool properties can be saved with the surreal numbers, sadly, the real number system is the standard, and you bet I'm gonna make another video on that, but to conclude this wreck of a video, what is a limit? Basically, I recommend thinking of it not as a math operation. It's a tool to investigate the strange properties of 0 and infinity. Sure, when you're at university level, you have to use the epsilon delta definition and all that boring stuff, but until then, you'll hopefully have a good intuition on what a limit really is.